Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com program, brought to you by Techstrong and Fairwinds. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting panel ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, perhaps you'd like to rewatch or maybe share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab. You can find that Q&A tab on the right side of your screen, along with a few other options. You'll see that there's a chat tab, and we'd like you to use that for more general comments. So let us know what you think about today's program, or maybe even start warming it up now by letting us know from where you're tuning in. We do have a couple of polls that we'll be launching throughout today's program, so we would really like your participation there. And of course, before we close out, we will be giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program. So our topic today is Kubernetes Benchmark Report 2023. See how you compare. I'm joined by Danielle Cook, co-chair of CNCF Cartographos Working Group and VP at Fairwinds. Robert Brennan, Vice President of Product Development at Fairwinds. And Joe Pelletier, Vice President of Product Strategy at Fairwinds. So Danielle, Robert, and Joe, thank you so much for joining us. You want to go ahead and take the floor from here?
Yes, absolutely. So we'll first do a bit of intros for all of us. I'll go first. I am, as Cody mentioned, the co-chair of the CNCF Cartographos Working Group. So that's a working group where we worked on a cloud native maturity model, helping people onboard to Kubernetes, but also through their journey of using cloud native products, what solutions to use, what technology, what process, people, and whatnot you have to put in place. And then I'm also VP at Fairwinds. Robert, over to you.
Hey folks, I'm Robert Brennan, VP of Product Development here at Fairwinds. I focus on all the engineering efforts that go into our commercial platform for auditing Kubernetes clusters for issues with things like security, reliability, things like that.
And Joe?
Yep, my name is Joe Pelletier. I'm a product manager over here at Fairwinds, and so we help kind of shape the direction of our open source and our commercial software Fairwinds Insights, which we'll touch upon near the end of today's webinar.
Awesome. So we are here to talk about our benchmarking report. So we looked at over 150,000 workloads in Kubernetes and evaluated them against reliability issues, security issues, cost issues to see how are people configuring Kubernetes and are they doing it right? And are they following best practices? So we are going to take you through some of those results today. And really to help all of you understand this is what's happening in the industry, and this is how you might compare to your peers, or maybe perhaps identify some areas that you could work on yourself to improve the overall security, reliability, and cost efficiency. So we'll get into a little bit of how we do that a bit more, but I think the next slide is a question for you, just so we understand kind of who we have here, so we make sure we're talking at the right level for all of you. So it's, where are you in your Kubernetes journey? So the poll's up now, and it's, I'm learning about containers and Kubernetes, planning to use it in 6 to 12 months, using only testing development environments, or I'm using it in production. So just give it a few seconds.
Yeah, and it's always interesting to see the results here, because I think when we started doing this poll, it was probably 2 or 3 years ago, and the results are very different, I think, in terms of where folks are.
All right, cool. So let's see, lots of you are still learning about containers and Kubernetes, lots of planning to use it, and some of you are using it in production. So cool, great. So moving on, let's see okay. So we're going to get into the results. We're going to talk about how you compare. So the first thing to kind of call out as we're going through this is how to read the data. So we have done this benchmarking report for 2 years. So we did it, we looked at results and released in early 2022, and now we're releasing the 2023 results, which looks at the last year. So we've been able to compare those. So for each graph that we're going to show, we've looked at the percentage of workloads that were impacted. So for this example, you can see that in 2022, 46% of workloads, there was only 0 to 10% workloads impacted. Whereas when the orange number goes down for 2023, it means like it's not as good, right? You want 0 to 10% of workloads impacted because that means you're doing well.
Just to kind of add on to that, so the 46% there is the percentage of organizations that have very few of their workloads, right? 0 to 10% of their workloads affected. So back in 2022, we saw about half of organizations, roughly half their workloads were not impacted here, or sorry, roughly half of organizations had very few workloads impacted here. And as we move into 2023. That number decreased to only 21% of organizations have had this issue fixed for most of their workloads. So yeah, getting worse.
Yeah, and I was just going to say, and then as a result of that decreasing from the 0 to 10%, you can see that other segments of the data have shown increases, right? So like the segment of 21 to 30%, right? So a greater percentage of workloads in that in those organizations are now affected by some of the issues that you'll see in today's presentation.
Right.
And as we before we move into all the data, so Robert, you just said the key takeaway, what we're noticing and the trends after evaluating these workloads is we're not doing that great as an industry. Things are getting worse, not better. And there's could be a few reasons for that. More people are using Kubernetes. There's more workloads being put in, more people using in production. So, it's really for all of us as we go through this to go, okay, these are issues that need to be dealt with as adoption grows of Kubernetes. So let's jump into it. First, we're going to tackle reliability. And the first results are around missing memory limits and requests. And I think where we're going to start is, why is this important? Why do I have to care about memory limits and requests? So throw over to either of you, Joe or Robert.
Well, I'll kick it off to talk about requests. I think that's a little bit more of the the thing that is a general best practice across kind of all workload configuration. And anytime you deploy a workload, you want to at least be setting kind of the memory request, because it helps instruct Kubernetes how much memory should actually be allocated to this application, so that it knows how to then eventually scale that workload and be able to avoid any sort of like noisy neighbor type problems. In terms of limits, I think, Robert, you might have a little bit more context there to share. I think they both obviously go hand in hand, but I think there's also some good best practices around setting limits here too.
Yeah, I mean, for production workloads, we would typically tell folks to set requests and limits. We'll set both requests and limits and set them to the same value. Basically, if you think your application could at some point be using 1 gigabyte of memory, you should, that should be what you request. That should be what you tell Kubernetes. I might at any point need 1 gigabyte of memory, so please reserve that for me. But there may be cases for like development workloads, QA workloads, where you want to set limits above that, so that you're not, paying for that gigabyte all the time. Maybe you want to set limits at a gigabyte, and requests are only at 100 megabytes, just to make sure you have some room to spike up. But it's not production facing. It's not going to be the end of the world if you don't actually have that room available. But making sure both these things are set is a really good way to make sure your workload stays reliable. And if you do end up having like a memory leak or something like that, memory limits can help make sure that you catch that. Rather than just letting that workload eat up all the memory that's inside of your cluster.
Awesome. And so, overall here we see that, unfortunately, there's more workloads missing these memory limits and requests. So if you are missing them, go fix it. Next up, missing liveness and readiness probes. So here we have the 83% of organizations are not setting these. So this is actually an 18% increase year on year from last year. So let's talk a little bit about why this is important. Throw it over to either of you.
Yeah. So liveness and readiness probes are really how Kubernetes understands like how healthy your application is, right? As you say, you roll out a new deployment for your app. You've got your old pods are still serving traffic. The new pods start coming up. If there's a period of time where those new pods, the binary has started, but say they haven't connected to the database yet, or they aren't ready for some other reason, Kubernetes will start sending traffic there unless you tell it, here's how to tell if my application is ready to serve traffic. And so if you don't set liveness and readiness probes, you're basically setting yourself up for blips of downtime every time you release, every time there's a strange event, a scaling event, anything like that. You run the risk of accidentally directing traffic to pods that aren't yet ready to serve traffic. So these liveness and readiness probes are a great way to make sure your application stays healthy.
And kind of, Robert, when it comes down to setting the liveness and readiness probes, does it require a certain amount of context of what that application or workload does in order to set them correctly?
Absolutely, yeah. So Kubernetes will do a best effort to make sure there's there's a program running inside the container. But basically, you need to give Kubernetes an HTTP endpoint that it can hit, or a command it can run to make sure that your application is really indeed ready to serve traffic. And it's kind of up to you to implement that HTTP endpoint, say, and inside of that endpoint, make sure you only respond 200 if the database is live, if it's connected to, an Amazon S3 bucket, whatever it needs. Make sure that everything is in place for it to serve traffic within that endpoint, and otherwise, respond 500, 404, whatever it is.
Gotcha. And even just to kind of relate it back to the previous example of missing memory requests and limits, I mean, we're talking about how important it is to set, but the values that you set can sometimes be sort of a trial and error, right? You have to be able to figure out how much memory consumption is my workload using, and look at it during kind of, heavy traffic or heavy usage, or even kind of a more normal or lower, smaller usage. So I think being able to have good tooling in place that allows you to monitor those workloads and helps you identify sort of the low and high watermarks of usage is important to have proper memory requests and limits set as well.
Yeah, absolutely.
Awesome. So our next one is a new one for this year, so we don't have a comparison. And this is looking at missing replicas. So we have here 25% of organizations are running over half of their workloads without replicas. So again, let's start with, why is this important and why should I care?
I actually think, Robert, you should kick this one off, because this is new, and I'm personally still trying to understand why this is an important best practice.
Yeah, so this is basically a measure of how many instances of your application are running, how many pods are running at any given time. So Kubernetes will happily let you just run a single pod for, say, your API server, and most of the time, that will continue to serve traffic. It will continue to be fine. But if something happens, that pod runs out of memory, there's an exception somewhere in the code, and it crashes, there's not going to be anywhere to send traffic to until Kubernetes manages to restart that pod. So you may have, a minute plus of downtime, depending on how long it takes your application to start up and how long it takes the Kubernetes API to respond. So best practice is to have at least 3 instances of your application running at all times. That way, any 2 of them can go down, and you'll still be able to serve traffic without that one remaining pod.
And is this related to horizontal pod autoscaling, which is something that we've heard, other customers, try to get configured in their clusters?
Exactly. Yeah. So another thing we check, I don't think it's part of this presentation, but one thing we do check in Insights is making sure that you have a horizontal pod autoscaler attached to any deployment. And that makes sure that if you get a huge burst of traffic, Kubernetes can notice that and say, hey, we only started with 3 pods. I'm going to scale that up to 5 pods for now, because I just need more firepower to handle all this traffic that's coming at me right now. But this check is really checking the minimum, right? You might set your minimum for a non-production workload to be only 1 replica, because you don't care if you get a minute of downtime. But for production workloads, you really want to make sure you have a minimum of probably 3 replicas. Even if you're not getting any traffic right now, you want to make sure that if for some reason one of those pods fails, 2 of those pods fail, that third one is always there to catch incoming traffic.
Well, and it's, all of this is about reliability, right? So Kubernetes itself, the reason you use it, move to it, is so your workloads can be more reliable and more scalable. So if you're not doing these things right, you're not going to get the benefits of the platform.
Yeah.
We do have a question from one of our attendees, just out of curiosity, which 150,000 workloads were analyzed for this survey? By this, I mean, were there any company-specific production workloads?
So this is analyzed across a large number of companies, a large number of clusters. They're big companies, small companies. So we got a ton of data about this stuff, and there's very little bias in the data. I would say we have a pretty generic sample across the industry: staging, production, development, things like that.
Awesome. All right, so we're moving on to security theme. So, this one, we're just calling it out first. So 33% of organizations are running 90% or more of workloads with insecure capabilities. So that is not good. So we'll dig into this a little bit. You'll see the data here. So let's talk about, first of all, what is an insecure capability?
Yeah, so the Kubernetes API really will allow you to latch on to a bunch of Linux capabilities that can allow you to do some really interesting things if you're, a systems engineer. They can allow you to really kind of mess with the host nodes that your container is running on in interesting ways. But most applications, say an API server, a dashboard, anything like that, they don't really need to know about the underlying hardware. They don't need to mess with the host node in any way. And so they really shouldn't be messing with these capabilities at all. Sometimes you get, say an ingress controller or a security tool or something like that really does need this low-level access. But for the most part, your application development teams should not be doing these things. One of the tricky things about Kubernetes is it will actually give a lot of applications a few of these capabilities by default. Because, in the old days, applications were sometimes architected to need these types of capabilities. And it makes it easier to kind of onboard onto Kubernetes if those are kind of included by default. But they're not really secure things to have. They're not things your application should have access to, should need to have access to. And so it's important to specify in your configuration, please remove these capabilities from every one of my, application workloads. And as you see in this graph, most organizations just don't do this. They're either not aware that these capabilities are being attached to their workloads, or they just are apathetic to it. And so you can see in 2023, a third of organizations, for basically all of their workloads, they're continuing to request these insecure capabilities. So this is a huge issue. It's a really easy way to kind of pare down your security footprint. Make sure that if there is an intrusion into one of your clusters, an attacker, isn't able to escalate their permissions, get onto the host nodes, and spread throughout your cluster.
And I think the thing about these types of capabilities is they may not, if you have them on or off, you may not actually know, or if you have them enabled, where you have some of these insecure capabilities kind of enabled, which gives Kubernetes more of those permissions. Your app will run. You may not notice any problems with it, right? But granted, there's that new risk factor that you're introducing. So, spending that extra time to make sure that you either have policies in place that prevent those capabilities at the time of deployment, or that you're giving feedback to developers when they're writing their YAML or Helm charts that they may be accidentally introducing these insecure capabilities. Those are kind of important process steps to include as part of your development workflow.
Awesome. All right. Moving on, we're going to go to writable file systems. So here we see that 56% of organizations are unaware of the need to override these insecure defaults. I'm reading this out, and that's not good. So let's talk about writable file systems. What are they? Let's define them.
So basically, when you're running an application inside of Kubernetes, typically you want that container to be kind of a read-only thing. You don't want it to be changing its file system as it's running, because that could lead to non-deterministic behavior. It could also it means that when that pod restarts, anything that you've written to the disk is just going to be erased immediately. And it's also a security thing, because an attacker, if they get access to that container, if the file system is writable, they can mess with configuration files that are on there. They can download new scripts and binaries that they can run on that container. There's so much stuff that they can do if the file system is writable. And so we recommend in nearly every case locking it down and making the file system read-only. You can always attach a separate disk or a separate, make a specific folder writable if you do need some kind of write access. But making the file system, read-only by default is a great way to improve reliability and security as well.
So one of the things we talk about is making sure we enable developers to use Kubernetes and the platform faster. Like you said, lock it down. So does that get in the way of any, expediting development or shipping apps faster?
So I would say where it can get in the way is if you're trying to lift and shift an application into Kubernetes that may have been architected in a way that wasn't really container first. Mm-hmm. It may be using disk writes in order to perform its job. I would say that application probably isn't ready for Kubernetes just yet and needs to be re-architected before it gets in there. But you might be able to hack it in by making the file system writable. But in terms of once you have an application in Kubernetes, in terms of shipping faster, I would say making sure that file system is read-only is actually going to be a really good guardrail for teams to make sure they're not introducing a new regression where they're writing to the file system, which might work perfectly fine in their development environment. It's not going to work very well in Kubernetes. So it's really going to help you ship with more confidence to have this kind of check in place.
Yeah. And I would say that there's going to be a lot of best practices around security where it is a best practice, not to have a writable file system. But there are going to be exceptions to Robert's point, right? There might be legacy applications that, have been containerized and you are trying to move them to Kubernetes as quickly as possible. It's important at that point to be able to document exceptions, right? And so you do want, there may need to be a business reason to keep that writable for a period of time, but you want to be able to then have a sort of a risk register. Fairwinds Insights kind of provides this as well, where you're logging the fact that this is in place, and then you can also kind of, assign sort of a future owner to fix it, or even, set a resolution or audit resolution saying this is something that, is working by design. So having that risk register as a way to manage these types of issues is important long term as you look to kind of reduce tech debt.
Yeah, absolutely.
All right. Well, let's keep it moving. Let's talk about privilege escalation. So only just 10% of organizations have managed to lock down the majority of their environment. So let's talk about that. So explain, I don't know, Joe, if you want to go first this time talking about privilege escalation and what this means.
Yeah, I privilege escalation, I think, is one of those areas where it is actually a very common misconfiguration. I think it's very easy to actually enable this misconfiguration, and it goes back to that point of like organizations might be trying to get the application to run, so they end up providing a generous set of security permissions initially, and as a result, the application's running, but they don't go and revisit, whether or not they need privilege escalation in place. Robert, I'd be curious if you know of any sort of scenarios where you may need to have this enabled, or as just maybe an exception to the best practice.
Yeah, there are. It's very similar to the insecure capabilities check, where there are sometimes these system level workloads that are doing, they're kind of operating at the platform layer, right? They're helping Kubernetes do its thing. So ingress controllers, security tooling, things like that might need this permission in order to analyze what's going on inside of the host nodes and make sure, there's no attackers coming in. But for the vast majority of applications, things that are serving APIs, things that are, serving microservices, things like that, they really don't need this permission. And like you mentioned, Joe, it is really easy to turn on because it's on by default. It's one of these things that, Kubernetes, in hopes of being easier to use, just kind of left it on just to make sure that old applications run properly inside of Kubernetes. And they kind of leave it to you to tighten it down. And so one thing I'd like to point out about the graph we show here, and it's something that we've seen in several of these graphs where something is kind of not configured by default or configured poorly by default, and you kind of need to intervene in order to fix it. You kind of see this binary distribution where you see there are a lot of organizations with 0 to 10% of workloads affected, and there are a lot of organizations with 90 to 100% of their workloads affected, right? So that's showing you that there are some organizations who are very mature. They know this is a problem, and for the vast majority of their workloads, they have locked it down. And there's other organizations who aren't as mature, don't realize this is a problem. They might not be aware of it at all, and they haven't set this setting on any of their workloads because they're just they're mostly concerned is like, is my application running? I'm not even going to try and lock it down.
Right. Yeah, I think that definitely makes sense. And there's also what we're seeing, I think, with the trend is that there are for the companies where like it may have been enabled, there's a trend towards being able to start making progress against kind of locking that down and making sure that applications are tested to verify that they don't need those permissions. So that is kind of an increasing trend too. But it is interesting to see how the data is bimodal like that.
All right. Well, let's talk about running as root.
Probably the most popular example of a security misconfiguration in Kubernetes.
Well, and these findings are surprising because there was the CVE a year ago. Was it a year ago or 18 months ago where people were taking advantage of this when containers were allowed to run as root. So let's talk about that a little bit and then look at some of the findings because a lot of people have this problem.
I'll kick this one off because I think this is one of the areas that I can provide a little bit more light into.
Shine.
But I think similar to privilege escalation, it's very easy to have this misconfiguration. I think Kubernetes makes it easy to misconfigure this, if you will. But there have been examples of vulnerabilities in the past where as part of sort of that chain of attack, if you will, one of the steps along the way is that vulnerability, takes advantage of of root access in order to, then, do more damage to the system or then to kind of access the data that it's ultimately trying to access. And this is an area where defense in depth and making sure your applications aren't running as root becomes important. So we did share a link to that example of the vulnerability where one of the guidance was before the patch was available, actually set the workload to run as a non-root user, and that would help you mitigate the threat. And so I think, there are going to be classes of vulnerabilities like that, where if you have this enabled and setting the workload as a non-root user, you are providing some additional defense in depth to prevent, further escalation.
Well, and so the data here, what we're seeing is, again, things are getting worse, not better here. So, whereas last year, 30% of organizations had this solved, if you will, now it's only down to 12%. And you can see the orange is increasing as you go down, 71 to 80% of workloads were impacted, 22%. I know that's a lot of numbers and it makes my eyes spin a little bit, but it's not good. And it's a simple step here, right?
Yeah.
Yep.
All right. So I think this is our last security one. The next one around image. Oh, no, there's two. There's another one on security. This one is on image vulnerabilities. Robert, you want to talk to me a bit about that?
Yeah. So for every container that you're putting in Kubernetes, there's a few things inside that container. Typically, there's a base operating system, so it might be running on Alpine or Ubuntu, and that's usually pinned at a specific version. There's a whole bunch of software that you might layer on top of it. If it's a PHP app, you might need to install PHP. You might need access to curl and Git and all those things. And then the last bit is your own application, right? Your code gets bundled in there as well. And so at each of those three layers, there can be known vulnerabilities that are running inside your container. So Ubuntu might announce like, hey, we had a bug. There's a security flaw in some of the core operating system. One of the applications that you're layering on top, like PHP, might have a security issue in it. And your application might be importing a library, say, that has a known vulnerability. And so it's important to make sure that you're scanning all your container images for those known vulnerabilities and making sure that for any critical ones, you're getting them patched relatively quickly. They're not exploitable, but it's important to make sure that you're getting those patched.
Yeah, and I think maybe one thing that just differentiates this is like all the examples we've been sharing before are really configuration, misconfigurations, right? So like in your YAML or Helm chart, these are, usually quick things that you can fix in order to improve reliability or security, et cetera. Images are, kind of separate, right? You have to scan the underlying image itself and fix the CVEs and known vulnerabilities associated with that. You kind of have to do both, right? And I would say just from an industry perspective, I think a lot of folks have gotten into image vulnerability scanning maybe long time ago, and have added sort of the configuration examples that we just shared as sort of a follow-on. So, doing both sort of infrastructure as code scanning or configuration scanning plus image vulnerability scanning is kind of the combination of best practices you want to pursue here.
Well, and I think this data is so interesting because, all of that makes perfect sense. And, vulnerability scanning, yes, we've, doing it in cybersecurity forever. But here we see, like, just in the last year that, it's gone from 9% to 25% of organizations that have issues on over 90% of their workloads. Like, that's a big jump. And is that, like, do we think that's because there's more vulnerabilities that are being announced and so people just can't keep up, or what do you think the symptom of that is?
Yeah, the tough thing is like, if you leave a container in Kubernetes for, I don't know, weeks, months, years, eventually vulnerabilities are going to get announced. Like every image eventually has a known vulnerability. It's just a matter of time, before it gets found. And so if you're not shipping quickly, rebuilding, fairly often, if you're say, you when you're creating your cluster, you install Nginx Ingress on day one and you never look at it again, 6 months from now, it's going to be full of vulnerabilities, full of known vulnerabilities because you haven't updated. So I think this is mostly a product of folks not staying up to date, not making sure that they're shipping not only their applications, but all the underlying platform infrastructure needs to be getting updated, needs to be getting, pulling in the latest versions, things like that.
All right. Last one on security. So we have outdated Helm charts, but then we also have outdated container images. So we started scanning for container images this year. So that's new data. In terms of outdated Helm charts, there's almost 50% of organizations have 50% of their workloads impacted. And then when it comes to outdated container images, like there's again two extremes. So we talked about that before. It's either, everyone has it locked down or people are probably not even aware that it's an issue. So let's first talk about why outdated Helm charts is a problem.
Yeah, I mean, I'll start at this at a high level. I think this is sort of the remediation aspect to the previous slide around if you have image vulnerabilities, right? Like, what are you supposed to do in terms of remediating those issues? And it depends on the type of image you're using. I think when it comes to Kubernetes, there's the concept of like first-party images. So these are the images that your company organization are creating, and you own the entirety of that image, right? And then there also might be third-party images or third-party Helm charts, and these might be add-ons or supporting, open source tools and software that you're installing into Kubernetes so that you can do things like ingress controllers or DNS, et cetera. And I think when it comes to that there's dozens of potentially, third-party open source software that you're running inside your Kubernetes cluster. And a lot of times the fastest, most effective way to reduce risks there is by just upgrading to the more recent version. And the Fairwinds Insight software recommends the version to upgrade to that has the least number of vulnerabilities. But we also have open source tools like Nova, which tell you if there's newer versions available. Robert, anything to add to that?
No, I think you nailed it. I would just add that it's not just about security, right? It's about reliability. It's about making sure that bugs are getting patched. Like not every bug is a security issue, right? Sometimes there's just a bug that would annoy your users, disrupt traffic, things like that gets patched. So making sure you're staying up to date is super important.
All right. Well, now we're going to move on to the cost side of the house. So we're starting out with this big stat, which is 50% of workloads have memory limits set too high. So that is going to waste some cloud resources. And I know, as we are in the environment we're living in, there is no time to waste or no budget to be wasted. So we'll dig into it a little bit around memory limits are too high. So why does this matter?
Yeah, I mean the big issue here is that you're potentially overspending. Memory limits being too high is a little bit more of you might not catch issues with like say a memory leak, and you might allow an application to like eat a little bit more memory than it actually needs for a while. Generally speaking, you want to make sure you've tuned your memory limits to something sensible that your application might actually need to use, rather than just saying okay, I'm going to set it to 20 gigabytes of memory because my application will never actually hit that point.
Yeah. Yeah, I mean, I totally agree. And in fact, I even think the next slide, not to push us on to the next one quickly, but I think the next slide actually kind of talks a little bit about where you can really have, overrun or over provisioned workloads, right? So whenever you set memory requests, it's sort of like the minimum amount of memory, or even on CPU side, the minimum amount of CPU that application is going to be allocated. But what we find is oftentimes organizations are setting at least 30% more memory or CPU than they actually need, and as a result, you're kind of you're allocating too much compute, and you're having to pay for that compute if you're in the cloud, right? And I actually think the problem becomes more kind of tricky when you're on premise, because if you have a finite number of servers and you're over provisioning workloads, or having requests set too high on premise, then you're eating up your finite compute capacity there. And I know that we've worked with organizations in the past who have properly right-sized their containers to make sure that they, using our software in order to make sure that they are setting the right amount of memory and CPU, and have, as a result, freed up servers on premise so that they didn't have to go out and make that capital investment, right? So I think it can be a pretty important setting if you're looking at the grand scheme of how do I make sure Kubernetes, I'm getting the most efficiency and ROI with my Kubernetes investment.
Yeah. I'll just add, as a developer, oftentimes what I want to do is just get my application running. I have a mandate like, hey, we want to ship this thing by this date, and I'm like, okay, let's get it running. I don't know how much memory it's going to use in production when it's really serving live traffic, and so I will just start by saying, give it 10 gigabytes of memory. That seems like enough. And then maybe that's okay on day one, but you really want to look at the production traffic and say, okay, well, it's really only using 1 gigabyte of memory. So we're overspending by 10x if we leave it as is. We really want to tune that down more in line with what it's actually using. And a lot of times development teams don't take that second step because they don't really have a mandate to from the organization, right? They're often shipping new features. And so they forget about it, they leave it, and, they're just, wasting money basically.
Well, and I think we're all seeing that that's changing slightly, changing as FinOps becomes more adopted in organizations. They're starting to investigate the cloud spend, and that layer that's trickling down to, okay, well, what's happening in Kubernetes? And as stakeholders come to the table and you have your FinOps organization, it's really important that developers and engineers are starting to pay attention to these settings because the finance teams are paying attention to it. So we've talked a lot about things aren't great, but we do have some encouraging news. So what we're finding is that when organizations implement Kubernetes guardrails, so whether it's shift left or before they can deploy, they're actually identifying these issues earlier and fixing them. So they're not reaching production. So in this case of looking at memory configurations, people are starting to save money because they're actually fixing it. It's not reaching the production. So Robert or Joe, do you want to add anything to that?
I'll just say, as a developer, I really appreciate getting these findings kind of pushed back into my development process, into like a CI/CD scenario. What's really annoying is if I ship a new feature, it's off my plate, I've closed out the ticket, and then 2 days later, a security engineer or an ops engineer bugs me and is like, hey, your thing is running as root. It's requested way too much memory and CPU, whatever it is. I have to go and open up a new ticket, open up a new pull request. I have to context switch out of whatever I've started doing now. And it slows me down an incredible amount. And so getting that feedback when I open up the initial PR, as a CI/CD check saying, hey, you did this wrong, you need to do this for it to be production ready. I get that feedback immediately. It's before it gets merged, before I close out the original ticket. And I can just make that change immediately, and I can be sure that when it goes off into production, it's actually production ready, and I'm not going to get bugged again 2 days, 3 days later.
So it's the benefit of, hey, I'm getting security benefits, I'm getting reliability, I'm getting cost efficiency, but I'm also improving developer velocity.
Exactly.
All right, so moving on. So we've talked to all the problems, and if you're sitting there going, great, but how am I going to audit everything to understand like where these problems are? We're going to tell you about that next. So Joe, do you want to talk about Fairwinds Insights a bit?
Yeah, we'll do it pretty quick. So Fairwinds Insights, it's our Kubernetes governance software. It's a software as a service platform that we use to help folks gain visibility into these types of issues in their Kubernetes clusters. So it could be any cluster running on premise or any cloud. We work kind of with any Kubernetes environment. And we provide integrations into both kind of CI/CD and GitHub so that you can catch these issues right at the time of a pull request, all the way through to deployment. So you can set policies that prevent misconfigurations into your cluster in the first place, as well as audit your existing cluster if you're just getting started, trying to understand what risk is or what problems kind of exist today. So I think on the next slide, yeah, so this is a great kind of overview of just sort of the different areas that we focus on. And what we're finding is a lot of companies who are moving to Kubernetes for the first time, they're going from sort of their POC where they've been running in, testing or staging and have, moved to production. I think our survey says about a third of the audience is now in production. And now they're thinking about what else do I need in order to manage my cluster and support even more teams and onboard more teams to Kubernetes. And oftentimes that means that platform engineering team, they need to be able to serve as many teams as they can without, adding headcount to their own operations. And so being able to push and provide security feedback to developers and app teams is important. Being able to kind of allocate and measure cost and then, provide that visibility in sort of a showback type mechanism, that also becomes important, especially as workloads run on Kubernetes. And we wrap this all up with guardrails. So guardrails are ways to kind of either warn or block on different types of scenarios. So I'll share my screen here just briefly to give you a little bit of a sense of what the platform looks like and kind of what's available to you as a next step. So I think y'all can see my screen now, right?
It's loading. There it is.
Awesome.
Got it.
Cool. So the main, landing page here for Fairwinds Insights is what we call action items, and it's really just like a big summary view of the different types of problems we have found in a given cluster. And you can see here that we actually categorize all the issues across the same categories we shared in this presentation: kind of security, reliability, efficiency. We also, put a severity on different issues. So this helps with prioritization. And if I were to kind of focus on, maybe I want to kind of look at what my high or critical severity issues are under security, I can quickly get a sense of some of the same problems that we shared today. Applications or workloads that are running as a root user. We do provide sort of detailed recommendations on how to fix those issues. And you can also, integrate those issues into backlogs so that and automate this so that, it doesn't require sort of a human. Insights can actually create these tickets into the backlogs of teams so that they can respond to it and fix them over time. We also provide this same type of information in what we call like a repository scanning, or think of this as integrating with your GitHub or repos, or even as part of a CI/CD pipeline. And we can scan infrastructure as code for issues like, file system should be read-only, or even kind of support different custom checks, like making sure labels are added to your workloads as well. So let's see if I can find a example of what that looks like. Yeah, so we can even support custom open policy agent checks that might do things like making sure labels are added as well. So lots of different capability out of the box here. We also provide kind of efficiency and cost allocation, so that when it comes down to understanding how much does my workload actually cost me, or how much does a cluster actually cost, we can provide that summary view as well. The one thing I did want to share is we have a new trial, or rather a free tier available of Fairwinds Insights. And if you go to fairwinds.com and navigate to the pricing page, you'll see that there's this free tier. You can sign up immediately today, and it's very generous. It has all the functionality I shared today, and just has a few different usage limits so that you can get a flavor of how this works. And if you have, any questions, we also have a Slack community, which you'll be able to get a link to go and log in and ask questions as well. So let us know what you think, and that's sort of the 2-minute overview of Fairwinds Insights.
Awesome. So I think our last, we just have two minor little slides to go through. One is our last polling question. So let's see. And this is just asking, what is your greatest opportunity to improve your Kubernetes environment? So a number of questions there. So we'll give this a few seconds to go. And while that's going, I'll just click to the next one. You have the pricing link. We do have the full benchmark report that you can get and download, so you can read the findings and details. That link is there, and I'm sure it will be sent out with follow-up. So we'll just wait a few more seconds. If there's any questions as well, feel free to put them in the Q&A while we're all here. Oh, and Dave has provided the pricing page and the link to the report, so that's there. All right, so getting help with the basics. All right, and then best practice assessment. So for all of you who did best practice assessment, you should definitely try out Insights and see some of what's happening.
Yeah, I would say one of the things that's unique about Fairwinds Insights is you'll see there's lots of great open source tooling in the market that really kind of focus on either maybe just reliability, or maybe just efficiency, or cost, or maybe just security. And we've tried to bring that all into a single solution. So the areas of security, reliability, and cost efficiency are all kind of something you can get up and running today with the free tier, and you'll definitely be able to achieve that general best practice assessment that way.
Great. All right. Well, I don't think there's any questions. If you do, we'll hang around for a little bit. I think Cody might be coming back on.
Yeah. So while we wait for some questions to roll in, I'll go ahead and give away a couple of gift cards and do a little bit of our closing housekeeping. So our 4 winners of our $25 Amazon gift card drawing are Shanna C, Tilanga M, Depot A, and Donna W. So to our 4 winners, please keep an eye on your inbox to claim your gift card. But if you don't happen to see that email, please do check your spam folder. And I'll also remind everyone that this session was recorded. So you will be receiving an email after we conclude today with a link to watch this program on demand. Or, of course, you can find it living on the Container Journal website at containerjournal.com/webinars. All right, have we received any more questions?
I don't think so.
Awesome.
Well, thank you so much for having us.
Thank you. Take care.
Thanks, Cody.
Sure thing. To Danielle, Robert, Joe, thank you all so much for joining us today. I'd like to thank Fairwinds for putting on today's program, and to our audience who's been with us for the past hour, thank you so much for being here. We really appreciate your time, and we also really appreciate your feedback. So as soon as we close out, there will be a survey that pops up on your screen. So please tell us what you liked about today's program, or maybe what you'd like to see on a future program. Otherwise, we'd hope to see everyone at an upcoming Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, everyone.
Thanks, John.